Okay, so we are live. Hello, everyone from DevSecond Poland community. It's a pleasure to have all of you here. I mean, all of you that will be watching later after the recording, all of you that will be connected with us live right now. It's very special today because first we have a very good, a very nice guest, I would say, that will be presenting, that will be talking about pod security, which is something very important nowadays. Yeah, because more and more applications are moving to the containerized standard or to the containerized world. And it's very important that we know how to apply the proper security to that, how we take care of our applications in this new world sort of saying. And it's very important to listen and to understand about these best practices, tools, processes, and whatever can help us to make sure that our applications will be secure. Also, from the code perspective, from the infrastructure perspective, in any kind of ways. So, I will be presenting our guest in a moment, but first, I want to tell you that we are being, how to say, maybe almost a year without sessions in the DevSecond Poland. Yes, there was a lot of going on, and we'll be having another session on next week. So we already invited for the next session, and before the end of the year, pretty sure that we'll be having another session in person, face to face, so we can have an opportunity to grab a beer together, and of course meet each other from the community. And of course, the main goal is to share knowledge and to meet people, which is the most important for our community. Okay, so no more talking from my side. The whole idea here is to present our guest, which is Chris. I will not try to say the second name because it's always awful when I misspell people's name. But Chris is here with us. Welcome, Chris. So please introduce yourself, talk a bit about what you are doing, where you're from, what are you doing in your life, and then you feel free also to present your content. Welcome.
Hi, thanks for having me. I will similarly kind of evade embarrassing myself by trying to pronounce your name, but for the record, it's Nesbitt-Smith, which to me is probably easy for English, non-English speaking, or at least when it's not your first language, perhaps not quite so obvious. So yeah, well, thank you very much for having me. Thank you very much for the intro. Can we pop the slides up if that's all right, and I'll crack on with that with some actual kind of bits. Thanks. Awesome. So hello. Well, yeah, thanks for joining me. So it'd be great for anyone that's kind of joining online, whether you're kind of watching this live or kind of watching this asynchronously at a time in the future. If you could drop a comment in the chat and let me know kind of where you're actually joining from, that'd be great to hear from you and make this a bit more kind of engaging. Yeah, as I say, I'm Chris Nesbitt-Smith. I'm based in London and currently work with some kind of well-known brands like LearnK8, Control Plane, eSynergy, and also some various bits of UK government. I'm also a tinkerer of open source stuff. I've been using and also abusing Kubernetes in production since it was 0.4. So believe me when I say it's been a journey. I've definitely got the scars and war wounds to show for it. We'll have time for questions at the end, or find me on the DevSecCon Discord community, where we can chat about any of the bits. Cool. Hi, Merchant. So, whilst we're not all online and not all watching this synchronously, but so for a little bit of participation at least, if you could drop me a comment in the thing and tell me, who's worked with pods before? By some show of hands, and I'll give the folk that are watching online a chance to respond. Cool. Okay, a little bit. So cool. And for anyone that hasn't raised their hand or made a comment, well, welcome to the party. You've almost missed it. So pods are the smallest deployable units of computing that you can create and then manage in Kubernetes. They represent a single instance of a containerized application running in your cluster. Okay, so now for the topic of this talk, though, pod security policies. Well, they've been around since version 1.0 of Kubernetes, which is approximately 1 million Kubernetes years. And in that time, they've actually never made it past the beta classification of the API. And I believe it actually may be the very last V1 Beta 1 resource that is routinely still used today in production. That is after Ingress left beta, not in the grand scheme of normal years that long ago. Kubernetes, a long time. Sadly, that's not going to be the case for PSPs or pod security policies. They were deprecated in 1.21 and were removed entirely in 1.25. So what is a PSP, apart from more words than should probably ever be on a slide? Well, that's perhaps a bit better. So PSPs give cluster administrators an ability to impose limits over things like, say, running as root, opening ports on the hosts, types of volumes that you can use, and so on. So if you've not seen one before, it looks something like this. Give you a chance to digest. So I wonder if anyone can drop me a comment and tell me what this container might be able to do. Say if a remote code exploit is found in my code, or my code goes bad. So perhaps maybe that that image has got a log4j in it, perhaps. Cool. So whilst you think about what that might be, let's have a quick play. So I've got a cluster already set up. So what I can do is I can run a. Hopefully you can see this. I'll tear up RM here. So I'm just going to run a Debian image. I'm going to call it unprivileged. We'll need to run like a bash at the end of it. So what this is going to do is it's just going to start a container, which we'll see running as a pod at the bottom here in a sec. Which might take a minute just to pull down the container so we can see it's creating there. Give it a sec to boot. Yeah, so elevation of privilege is roughly yes, that's what's possible, but you might be lulled into thinking that was perhaps just limited to the pod, perhaps, right? So this is as a unprivileged container. So if I were to let's scrap out this, that's okay, get pods, unpriv, YAML. So we'll see the security context here, wherever that is, pipe it via YQ, so I get some syntax highlighting. So we can see the security context is defined empty, right? So I don't have the any kind of privileges in this particular pod that I've got running now. Oops. Okay. Cool. Now, if I do a so I can do like ls dev. So what I'm seeing here is I'm seeing a sandboxed environment. So this is what you'd normally expect to see in a container that's unprivileged, right? So I've got a quite limited view of the world, and I've got a limited amount of things that I can do inside this container. So granted, I am running as root, but I have the C groups and namespaces are limiting down what I can see and do by the kernel. So this is all great, right? Okay, so let's have another look and try that as a privileged pod. So let's run this here, and again we'll run bash. Dash privileged is going to do create me a privileged container, which we can have a look at in a sec. So let's just look at what that actually looks like as a pod spec. Priv YAML pipe to YQ for syntax highlighting. So we can see the security context here. We've got privileged is true. Well, reasonably innocuous, not too obvious about kind of really what's kind of going on, right? So let's now see. We'll see if we can spot the difference. It's a lot more, right? So because I'm privileged, I'm not bound by so many of the namespaces. So I'm now kind of sharing the host namespace. Now, you might think, well, fine, I've got to make a pod able to, or a container able to be privileged because reasons. Maybe there's something that you might want to give it access to. But what that kind of one extra kind of tiny bit of YAML actually has allowed me to do is see the entire kind of machine. So you might kind of go, well, fine, well, I'm still in a container, right? So if I do like slash, like that's still the root file system of the container, right? Well, yes, but with the added benefit of like the /dev and also the /proc, that I've now got the entire host kind of contents of those, I can start to do some interesting things. So let's have a look. So what I can do, because I've got the root file system, I can do something like this. So I'm going to make a directory on slash, call it foo. I'm going to mount /dev/vda1 to that directory. Now, to know that is on this particular cluster, which is just a kind instance, is the root file system of the host node. And I'm going to mount it to /foo. Okay, so I've done that. That's probably reasonably alarming. So if you've allowed that to happen in your cluster, as a cluster administrator, you've not stopped this sort of thing happening, all of a sudden you've kind of lost that node effectively, right? So I, as a bad actor, I own this node. I can basically kind of do, if I cd /foo, I can see everything on that host machine. Bad day, right? So I could go and format the disk. I could do all sorts of bad, nefarious things. All the kind of stuff in proc and network interfaces. I own the entire node. It's mine now, basically, right? Well, you might think that kind of your day's over and that's as bad as it's going to get, right? So maybe you might think, well, what we'll do is for privileged pods, we'll make them run on, say, a isolated node, for example, which you might be lulled into thinking provides a boundary, like a blast radius of what that pod can do. Sadly not, though. So because I'm too lazy, I could go and find some things myself here. I can go and download some binaries or whatever from the internet. But let's perhaps maybe assume that this pod doesn't have internet connectivity, or then the cluster doesn't have outbound connectivity. Maybe it's in an air gap. And I'm going to guess that somewhere on this node, probably, there is kubectl. Now, this is all because I'm lazy, right? I could just tunnel and talk straight to the Kubernetes API via it, because it's all underneath the hood. It's all HTTP. So I could craft the payloads and just send them raw over a network socket if I didn't have the tools available to me. But let's just assume that somewhere on the cluster, or somewhere on the node rather, there is the kubectl binary that's going to be compatible with the version of Kubernetes that's running on the cluster. As I say, I could find plenty of other ways to get myself there if not. So what I've just done is I've kind of added to my current path the first instance of where the find has found kubectl. So now I can do okay path, and I'll see that it's managed to find one in here, and it's added that to the path. So now I can do kubectl, get pods, right? Now, quite rightly so, what it's saying, well, at the minute, right, the name, I'm now using the identity of the pod. Now, the identity of this pod happens to be the default one in the default namespace. Well, So it's the system service account default. Okay, well, so I can't do anything as that service account. So you might go, cool, well, jobs are good, right? The day's over. Well, not quite so fast. So what's also on this node is going to be the kubelets identity. Every node in Kubernetes has an agent that's running on the node, and it talks to the Kubernetes API, and it wants to know, say, what pods are allocated to that node, and then it will start them up. So obviously, this node needs to have a permission somewhere in order to be able to talk to the API server. So let's kind of do that, which should hopefully have done that correctly. And I'm just also going to be lazy. I'm just going to use the kubelets config as well. So similarly again, I'm going to do that. Okay, now let's see if my magic has worked. Sorry, I don't have the alias. Cool. Okay, so now I'm in the pod and I'm able to see my own pod, right? So I can see my own pod in because that's the only pod that's running in the namespace. So as you can see down here, I've got the same output that I'm able to do as a cluster admin. What I can also do is I can get all the other pods in the cluster. I can see all of the pods. Now these they happen to all be on this single node cluster, but they could be running on any other pod. Now you might think, well, that's not such a bad thing, right? Because if I do, say, I don't know, this pod, for example, kubectl exec ti namespace kube system sh, right? I'll get told, well, you can't do that, right? Because, which kind of makes sense, right? So what this is basically saying is that the API server has said, well, you're acting as the kubelet. So we can see that that the user is now, rather than what we saw before, was a namespace service account for the thing. I'm now using the identity of the node. Well, it can't kind of create it can't exec into a pod, right? So it can't create that resource, which is kind of what you need to be able to do to exec a thing. Well, so you might think, well, fine, okay, well, I can't do very much. But what I can do is I can cordon nodes. I can label nodes. So I can manipulate how I'm represented to the cluster. I can look at the status of other nodes, taints and tolerations, and mimic those in order to push workload away from other nodes and also attract it to my own and convince the Kube API server that I'm able to run all of it. Now, what can that allow me to do? Well, that will allow me to do all sorts of other exciting things around, like, well, I can go and see all the secrets. I can go and get all the data. Because I've got the container runtime of the host machine, I can basically just do Docker exec into all the containers. It's beginning to look like a really bad day. I can also do, say, eBPF interception of kind of kernel-wide activity that might be some network interface, and intercept that and manipulate it, or all sorts of other kind of weird and wonderful things that I could do. Basically, you've lost your cluster and everything on it. I own all of that now. So I've gone from a pod to a node. Well, now I own your entire cluster. This is a bad day for anyone that's looking after this cluster. So, what are the answers? That was a spoiler. Right. So, let's come back to the slides. Okay, so a bit more obvious, but again, this pod will provide you with kind of a game over under the same terms as before. So as we can see, we've mounted a host path volume into a pod of the host path of / and we've dumped that into storage. I can do just as much as I could do as I just did before, even without a privileged pod. Okay, so similarly, this one. Well, again, I've not said it's privileged, but it will still allow me, based on I'm going to be on the host network namespace, I've got the ability to, say, masquerade as other things to the network. So I could maybe be 443 or 80 and get traffic that was perhaps intended for, say, a cluster-wide ingress, or talk to and masquerade with all sorts of local systems to the host, like X, for example, if that's running dbus, iSCSI, and indeed the container runtime. Bit more involved, but game over until you've just got a few more hoops to jump through to get to root. So basically, leave any one of these kind of control in the PSP open, pod security policy open, and you can be kind of one bad pod away from losing absolutely everything. A bad day all round. So PSPs sound like a great idea, right? Awesome. But not quite so fast, bucko. There's a whole heap of usability issues that you might have encountered if you tried to use them in anger before now. So the policy is based on the user that created the pod, not the workload. But if you're creating pods with, say, CI, for example, that might require you to have, say, multiple identities to authenticate to the API server with. But when was the last time that you created a pod and not a deployment or a stateful set or whatever else is a higher level of abstraction? Well, in that case, the identity creating the pod is the service account for that controller. Some of the parameters aren't simply admission controllers that accept or reject, but mutating this is not clear. So the order of evaluation can also be confusing and unpredictable with multiple policies all overlapping scope, and especially if some are mutating the configuration. And it only applies to new pods, right? So you can write a policy, but it won't actually apply to anything that's already in the cluster, which could well mean that when you update the policy, that it will break your production applications later down the line when they happen to try and reschedule or fail. So maybe on, say, a scale event, when your autoscaler starts ramping up the number of pods, they now can't schedule. So you've said I want 10 replicas, and you've got 3 running, but they're not going to ever get scheduled because the PSP is going to say no, or perhaps a node failure, right? So what are the alternatives that we should look at? Well, the clock has now elapsed, and we are now kind of well and truly past 1.25. We are what 28 now. Though olders are still supported, particularly if you're in managed cloud. The older ones that still support PSPs are still kind of current and maintained. Well, there's a fair amount of choice. So here's just a few kind of shiny ones. Then you can, of course, write your own. It's fundamentally just a webhook to interact with. So I'm going to focus on a few because with a little help, they provide a straightforward-ish migration journey. So there is an in-tree answer, i.e. it's now built into Kubernetes. So you might say, well, why am I not pointing at that, grabbing kind of a drink and just walking off stage and mic drop, right? Well, pod security standards are most easily thought of as kind of 3 rigidly defined, predefined pod security policies. So these are kind of privileged. Basically, anything goes, and is actually the same really as not defining a policy at all. You've got baselines. Baselines are middle ground, so stops most of the super obvious stuff. And most of your stuff should run at this level without much change, right? In general. And then restricted. So this is the most restrictive policies, and it stops most things. You should aspire to run stuff here, but realistically, you'll probably have issues in the real world. So these are rigid universal policies, which sound great. It's super easy to communicate these between teams, test against them, and there's absolutely no confusion when deploying between different clusters. So happy days, sounds great, right? Sadly not, and for a few reasons. So ideally, you'd run all of your workload at restricted, but inevitably there'll be some things that can't quite fit that. Well, restrictions are applied on a namespace level, and you can apply some kind of exemptions in order to drop the thing down, but it's only going to be a massive step down. And it's not just for the container; it'll be for the pod. And you have to do it down from like restricted or baseline. From privilege. From restricted down to privileged. In which case, that's quite a lot. When actually all you wanted to do was a relaxed kind of one of what would have been a pod security policy. And indeed, it's applied with a label on a namespace, not even kind of an annotation. So, well, what is it good for? Well, the only thing I can see that this is possibly good for is if you're a software vendor that's building products to run on Kubernetes. And if you're mad enough to be in that business, then if you can make your product run in restricted, it will give you a good head start for whatever unique configuration your customers may have implemented and demonstrate that you've also considered the security implications of your product. Okay, so how do we migrate all of our old legacy PSPs to something new? Well, there is unfortunately no simple like-for-like mapping. The pod security policy and any of the replacements behave slightly differently, and for good reason too. If you've been using pod security policy for a while, you've likely developed some quite complex rules which have become entangled with those usability issues. So generally, I would encourage you to take the opportunity to refactor and simplify rather than just trying to kind of lift and shift, and continue what you've been doing up until now. That said, there has been some work to ease the transition by reproducing the key capabilities and even calling them the same things in some cases. So the short answer is, drum roll, use a whiz-bang super-duper tool that I made. So simply provide your existing PSP and take your pick of policy engine from Kyverno, Keyboard, or Gatekeeper. Let the GIF play out. So that was to Gatekeeper, to Keyboard, and I only went to one thing. We'll have a look at it in a minute. Or just paste it into a simple web app where it runs in a browser, and let your browser kind of do the work of doing the conversion for you. So, live demo. So we can take, with a bit of luck, this will work. So, wrong direction. Okay, so here we go. So this is on appvia.github.io/psp-migration. So what we've got here is a kind of a really pretty, excuse me, words, a very permissive policy. So basically, it said kind of anything goes, really. And this is what that kind of anything goes policy looks like in Gatekeeper, or is similarly in Keyboard and Kyverno as well. So let's have a look. So let's now define, say that let's swap this to being true. With a bit of luck, hopefully. Live demo. So here's, we'll come back to the Gatekeeper one, maybe, if it's going to work, maybe not. That's live demos. So here we can see a Keyboard implementation of that. So we can see that that says that that it would set these settings. And we can see a Kyverno one that looks something like this for the same reason. And we can see, it's not going to work. Cool. I will stop tempting more fate with that. But we could kind of have a look at, say, a baseline PSP. So something looks like that, and see what that looks like when it thinks about it. Maybe. There we go. Fine. Okay, it's a bit more involved. So a more complex policy that looks something like this. So this is the equivalent of what baseline looks like as a policy. So it's taken straight from the Kubernetes website. And this is what, if you were to apply the baseline security policy, as I said, kind of referenced earlier, this is actually kind of the implementation that runs from in a kind of old translated fashion of what would be pod security policy. So we can see we've kind of limit down these, we limit down some volumes, pretty permissive, as you can see, like you've got all sorts of stuff that you can do. We've said you can't have the host network, you can't have host PID or host IPC. And this is what that might look like in Kyverno, in Keyboard, and Gatekeeper. Oh, Gatekeeper's working now. Cool. So this is what that might look like in as Gatekeeper config. Cool. Okay. So what we just did is we converted our PSP seamlessly to, say, Caverno, Cube Warden, or indeed into Gatekeeper. So that was easy, right? But should you do this? Well, don't be fooled. Just because I made a tool and wrote a big blog, and doesn't mean that I think any of this is even a remotely good idea for the vast majority of use cases. But it perhaps at least got your attention. So using a cluster enforced policy doesn't really guarantee any real security. So you may well find it's as a cure, it's worse than the disease. So we're seeing more and more vulnerabilities and in the wild attacks that cluster enforced policy fundamentally wouldn't protect against. So if you've been keeping up, you'll have realized that I've taken you on a kind of roller coaster journey of explaining a problem within Kubernetes and kind of Linux itself, a solution of PSP, another problem that PSPs are going or gone away, and another solution of a tool that I've built, and now another problem that undermines everything that I've just told you. Well, the good news is there are some answers. They are simple and old, but not easy. But I'm kind of beginning to kind of run out of time on this now, so you'll have to come back and find it out in another talk. But as a sign of some good faith, you can expect a kind of scenic walk through some buzzwords like these, and I'm excited to be able to share some hard but simple solutions that can provide a robust level of coverage and also advice on how to tackle the cultural change that kind of needs to go hand in hand with some of the tech. So thank you so much for your time. Hopefully this has been interesting, if not just a tease. Please do follow me on LinkedIn, Twitter, GitHub, and in the DevSecCon Discord as well. You can be rest assured there'll be little or no spam at all, since I'm pretty awful at self-promotion, especially on social media. CNS.me just points to my LinkedIn. The original content for this talk and some of the solutions that I've alluded to, including how to do policy as version code, are on kind of the appvia.io blog. Questions are very welcome on this or anything else. If I miss you, you're not watching this live, I'll try and keep an eye on the comments on the video, or of course, as I say, like in the Discord chat, or find me on LinkedIn as well. Cool. So, question of, does pods policy overwrite cluster policy? Does it make sense? So the pod security policy that I defined was a cluster-wide kind of limitation of what I could then do when what would be rejected. So if I said you can't have a privileged pod from a cluster perspective, from the pod security policy, when I went to go and do my kubectl run -- privileged, that pod would be rejected. It wouldn't let me run that. If that answers that question.
Yes, make totally sense. And I think in general was a very good presentation, a very good new topics, at least for me, I would say. I don't know from the audience. We have few people online, but I think people are shy today. What happened, guys? Let's show that our Polish community are engaged, Just Marcin, who is already an old friend, I would say, said hello in the beginning. I sent over some questions. If there are some questions from the audience online, please drop in now or silent yourself forever. But as Chris mentioned, he will be checking out on the comments after. You can also reach out on his social media and his links that he's just shared. Do you have a preference one, Chris, like Twitter or something special that you answer quickly,
I'm definitely not on Twitter, LinkedIn possibly, or the DevSecCon Discord, which at least bleeps my phone.
Cool.
And be good to obviously enjoy the rest of the community experience from that.
Cool. Yes. So if we don't have any more questions, guys, I really want to thank you, Chris, for the whole presentation and content that you shared. I think it's very useful. Do you have these slides available somewhere?
Yeah, so absolutely everything is on talks.cns.me. So you can find this and kind of any of the other material, and there's some other bits that are around this as more of a text form in the appvia.io/blog as well, with a bit of a write-up on kind of some of the thoughts behind this. and also how to do some of the things that I was alluding to, like setcomp profiles and AppArmor and SE Linux, like old things that you might remember from kind of prior to Kubernetes, things that actually still work and are still relevant despite all the new shiny things on top.
Cool. Awesome. So if no more questions from the audience, I think we can close for today. Chris, again, thank you for sharing. Thank you for engaging with our community. Once you are in Poland, please enjoy the city, enjoy the country. I think that's it. Marcin, if you're still there, thank you for joining. All the rest of the audience, thank you again for following up. People that will be watching this after also engage with us. Join the DevSecond community on the Discord. I think it's a very nice place to share, to exchange this information with everybody. Yeah. Also the how to say, all the participants and all the people which is sharing content over there. Mostly of them are on the Discord community, so we can just engage and exchange information there. I think it's a very nice place to build this community somehow. Huh? Again, Chris, thank you very much. I think we can close for today. If you have any last say goodbye or something like this, feel free. Yeah.
Oh no, thank you very much for having me. It's been a pleasure.
Cool. Thank you then. See you guys. Take care.